Hello everyone, my name is Gandhi Napitupulu. Uh, in this session, I will share about our research about identification of seasonal water mass characteristic in West Sumatra waters. The content is about introduction, data and method, result and discussion. The introduction our research because the western water of Sumatra are unique and complex. Because it's crossed by equator and flanked by Asian continent to Australian continent and Indian Ocean to the Pacific Ocean, making this water dynamic. The mass of water is from temperature, salinity, and density at a certain water depth. There are developed stratification in this the water vertically, affecting the stability of the water mass. The eastern Indian Ocean mass is dominated to major. There are subtropical Indian Ocean and Australian Mediterranean Sea. Many studies have been conducted on water mass characteristics in eastern Indian Ocean, but few have focused solely on water of western Sumatra. Therefore, this study aims to investigate the seasonal characteristics of water mass and to identify the factors that influence mixing in western water of Sumatra. This is the study area our research in West Sumatra. We use world ocean data from 2003 to 2019 from observation data. We use ocean data view to process data. According to TS diagram, there are six types of water mass found in West Sumatra. There are by Bengal Bay water, Indonesian upper water, South Indian Ocean Central water, Antarctic intermediate water, Red Sea Persian Gulf intermediate water, circumpolar deep water. Figure 3 shows the variation of water mass for the four seasons. The temperature varies at the surface before the thermocline layer. At low latitude station there are higher than at high latitude station during the western season, as shown by isothermal line rising at 28 Celsius. The ancestry distribution is clearly in the minimum range at higher latitude during the western season. During the west monsoon period, intense mixing occurs, shown by mixing occurrence at shallow water depth and wider range of water mass column. In contrast, the vivis period, the resistive values is generally higher towards station with higher latitude during the ice monsoon in GCA. Furthermore, during the transitional season, SON wind direction and currents are unstable and weak. The temperature difference between low and high latitude station is not particularly noticeable. In general, the water mass is unstable beneath in the thermocline layer 200 to 250 meters. The temperature distribution in longitude shown in figure 4a shows that the thermocline layer is deeper in the eastern than in west. It indicates the water mass is transported from the West Indian Ocean to the East Indian Ocean. Water temperature, particularly in Indonesian water, are influenced by the cycle changing season. The decrease of thermocline in the eastern R indicates the upwelling process. The thermocline in longitude 92 occur at 1 to 120 meters, while it occurs at shallow shallower than 100 meters in the longitude 98. Besides the upwelling caused by underwater current, the watering conditions also play a role in determining the thermocline depth in the region. Figure 4b shows salinity contours that vary with longitude. It shows that the salinity values are higher 92 to 94 than longitude 98. Therefore, the salinity pattern seems from the west to east. Interestingly, salinity is almost uniform in 35 base uring at depths more, more than 100. It happened due to mass transfer water from the West Indian Ocean and intrusion from the more saline western water mass. The dominant water mass flow toward the east is a depth 80 to 150 meters from the latitude 1.2 south latitude to 1.5 north latitude. Meanwhile, the current direction is westernward in the surface layer at a depth 250 to 500 meters is a current reversal between the equatorial undercurrent and the current in the surface layer. Figure 6 shows that the temperature in the west is higher than in the west, is indicating an upwelling process that occurs in the water West Sumatra. The characteristic of water mass carried from the West Indian Ocean allow it remain in West Sumatra water. The West Indian Ocean has a broader thermal process than the eastern region. This concept reveals that the temperatures are the particular this Indonesia is strongly influenced by the cycle of the changing season. Figure 7a shows that in the west monsoon, the vertical contour density varies from 22 to 24 kg per meter cubic and tends occur that 0 to 150 meters are higher at depth of 200 to 500 ranging from 26 to 30 kilogram per meter cubic. Meanwhile, during the MM transitional season, the density contour 22 to 24 kilogram per meter cubic occur at of shallower than 100 meter, and the density contour 26 to 27 occur at depth 250 to 500 meters. During the SSGGA is monsoon, the density range from 22 to 23 kg per meter cubic appears at 0 to 120 meters, and the density of 26 to 27 kg per meter cubic is a depth of more than 200. So this is the conclusion of our research that the temperature decline from the surface layer to depth, and the test diagram analysis reveals 6 different types of water mass, and horizontally temperature distribution in West Sumatra indicates the presence of upwelling phenomenon defined by the temperature difference of more than 2 Celsius every 100 meters. This is our reference. Thank you to Kios, MTCRC, Ocean Data View, and NOAA, so we can complete our research.